All right, today we're going to talk about perimeter and area of shapes. And perimeter, if you think about the rim of a shape, it's all the distance around the shape. So for perimeter, you mostly just have to count the length of the side. So if I'm looking at this shape here, I can count it's 4 by 4 by 4 by 4, and this is a perfect square. And so the perimeter of this shape would be a total of whatever 4 plus 4 plus 4 plus 4 is. So I could take 4 plus 4 plus 4 plus 4, and I could add them all up, and I would get a total of 16 for my perimeter there. Okay, this is a square. If I were to twist this shape, I still have a square. If I were to twist the shape again, now I get a square. Okay, it doesn't matter what way the shape is oriented, it is still a square as long as it has 4 equal sides and it has 4 right angles, and those opposite sides are parallel. So that's how you find the perimeter of a square. You just count the outside. Now, to count the area of a square, you have to count all the space inside. All right, and so since I have this on grid paper here, we could actually count how many squares there are here. There are 16 squares in there if I count 4 rows of 4, and I could calculate that by taking the length times the width. All right, so we have 4 by 4, and I could say length times width is 4 times 4, which is 16 squares. Now, instead of using length and width, we're going to use the term base and the term height. Okay, so we're going to try to get away from that length times width, and we're going to switch gears here to start saying base times height. Okay, still the same thing. To find the perimeter, you can count the outside, and to find the area, you're going to count all the inside. And the way that you count the inside is you multiply the base of the shape times the height of it. So that's how you find perimeter and area of a square. So let's take a look at a different shape here. All right, this shape has 2 sets of parallel sides. It has 4 right angles, and this is commonly known as a rectangle. If I twist it, it's still a rectangle. If I twist it, it's not a diamond or anything else, it's still a rectangle. All right, so I could count the perimeter of this shape. I can count the outside, 1, 2, 3, 4, and then I got 1, 2, 3, 4, 5, 6. So this is 4 by 6. All right, and this is 4 by 6. And if I want to find the perimeter of that, the rim, it's all the way around. I have 6 plus 4, which is 10, plus 6 plus 4, which is 10 again. So I have a perimeter of 20. All right, now to find the area of this shape, since I have it on grid, I could count it all, or I could multiply the base times the height. The base is 6, the height is 4, and so the area gives me 24. All right, the area is 24. My perimeter would just be 20. If I twist the shape, still the same numbers. Still have a distance of 20 around, area 24. If I twist it, it doesn't change the values. It just changes how it is oriented or how it looks. Okay, so for squares and rectangles, you just have to count the outside for perimeter, and to find the area, you got to multiply the base times the height. Okay, so we're going to throw in another shape here. This one looks like a rectangle that got slid over. All right, we have 2 sets of parallel sides. There's no right angles here, and so I could count the perimeter as long as I knew what these sides were. So I'm just gonna say I can count this side 1, 2, 3, 4, 5, 6, 7. This is 7 here, 7 here. You'd have to have this number here, so I'm just gonna pretend that this is 4. All right, just for the sake of this lesson here. So the perimeter of this shape would be 7 plus 4 plus 7 plus 4. My perimeter would be 11 plus 11, which is 22. Now to find the area of this shape, I know that area of these shapes is base times height. I could call this a base. If I twisted this, it's still a parallelogram. I could call this a base, but I don't know how high this is. So one way you have to think about this is, how could you maybe take this shape and make it into shape we know? We know these shapes, all right? So what could I do to this shape to make it look more like one of these? And so I might have to, okay, I got an idea. Here, let me cut this real quick. If I take this and I just cut it on one of these lengths that goes straight up and down, and that length makes a 90-degree corner there. All right, so I have a perfect corner. It's 90 degrees there. If I just cut that parallelogram right on one of those lines and I rearrange it, I get a much more familiar shape. It won't line up perfectly because my paper got bent a little bit there, but it looks now more like this one right here. All right, and I can look and I can count now my base. Oh, it's still 7. 1, 2, 3, 4, 5, 6, 7, and my height is 3. And so if I take my base, which is 7, and my height, which is 3, and I multiply them together, I'll find the area of that parallelogram. It's 21 units squared. So the same formula, okay? It's still base times height. It's still base times height, okay? For all 3 of these shapes. A parallelogram is basically just a rectangle that's mixed up, okay? A rectangle is a type of parallelogram, and a square is a type of parallelogram. So it makes sense that they have the same formulas to find the area. All right, so if I have a parallelogram, I just got to find out how tall it is, and I got to find out how long it is on the bottom, and I have to find out where those two things meet at a 90-degree angle, and that will be the height and the base. Okay, the height and the base are always touching at a 90-degree angle. All right, so that's how you find the perimeter and area for a parallelogram. Parallelogram, parallelogram, parallelogram. This is a special parallelogram. This is even more special parallelogram. All right.